Assalamualaikum warahmatullahi wabarakatuh. Today I would like to present about the schematic diagram of the pipe and duct flow based on the question we had been given. So basically, the steam enters the larger horizontal pipe with an inlet diameter of 16 centimeter. The steam is moving at 2 megapascal and 300 degrees Celsius with a velocity of 2.5 meter per second. Then the steam will exit through the smaller pipe with the diameter of 14 centimeter, and the exit conditions are 1.8 megapascal and 250 degrees Celsius. That's all from me. Thank you.
Hi, I'm Farid and I'm going to explain about the functions of pipe and duct. So piping system are used to distribute liquid, ductwork system are used to distribute gases. The mechanical system used to move the liquid is a pump and the mechanical system used to move the gas is a fan. So ducts are made typically of thin lightweight galvanized steel and or aluminum and they are used to distribute air and gases. Duct shape can be round, rectangular or oval. And lastly, pipes are made of steel, copper, cast iron and other heavier materials and they are used to distribute water and liquids. Pipe shape are always round. So that's all from me. Thank you.
Hi, my name is Firdaus. I'm going to be talking about the real-life application of pipe. The first one is it is used in process plant to deliver fluids from one point to another point in the process. The second one is it is used to make handrail to be crossed by the hand while descending or ascending escalators and stairways. And the final one is it is used for plumbing to transport pressurized and treated fresh water to a building and inside the building. Thank you.
The real-life application for a duct is used in an air conditioning system as a collection of tubes that distribute heated or cooled air to different rooms. Next, it is used in ventilation system. For example, it conveys smoke to the outside of the building. The last one is used in regenerative thermal oxidizer to control air pollution.
Assalamualaikum and a very good day to everyone. So I will continue with the presentation by explaining tutorial questions regarding pipe and duct flow, which is question 12. Question 12. Steam enters a long horizontal pipe with an inlet diameter of 16 cm at 2 megapascal and 300 degrees Celsius with a velocity of 2.5 meter per second. The exit conditions are 1.8 megapascal and 250 degrees Celsius and the diameter is 14 cm. Determine rate of heat transfer in kilojoule per second. So first and foremost, the draw of schematic diagram and assumption are quite important in order to answer the problem. So as you can see, this is a schematic diagram and the assumption made for this question is that first, the system is a steady flow process. Second, kinetic and potential energy changes are negligible. And the third one, there is no work interactions. So as the initial state is in steam when it enters the pipe, it is a superheated vapor. So we determine the specific volume and the enthalpy by referring from table 8 sheets at pressure 2 megapascal and temperature 300 degrees Celsius, which we will get the answer. The reason why they determine the specific volume and the enthalpy so that it will make the calculation of mass flow rate and the rate of heat transfer easier later on. So as we can see, the formula of mass flow rate is the density times velocity times cross-sectional area. So from the formula, density is equal to 1 over specific volume. So this is why we determine the specific volume before this. And we will get the final answer of the mass flow rate 0.4 kilogram per second as we have already known of the value needed. So for the energy balance system, change in the energy system is zero due to the steady flow process. So we will left with energy in equals to energy out. When we expand the formula, there is a few formula that can be cancelled, which is such as the change in the kinetic energy, change in the potential energy, and the work interaction. So we will left with the final formula is Q equals to mass flow rate equals to H1 minus H2. So I wrote Q out, so you can ignore that. Actually is a Q chain, and this correlate with the objective of the question where to determine rate of heat transfer in kilojoule per second. So we already know the mass flow rate, we already know the H1, but we don't know the H2. So we determine the H2 by referring table 8 where the condition is pressure equals to 1.8 megapascal and temperature equals to 250 degrees Celsius, which we will get the answer. So we insert all the final value into the final formula, so we will get the Q equals to 45 kilojoule per second. So that's all for me. Thank you.
Alright, I'm Tong Wei Lam. I will continue the presentation regarding. I would like to add on a few things regarding on the energy components of the system. In our case, the main energy component is the heat transfer, which is Q, while the change in as mentioned, the change in energy, kinetic energy and the potential energy is negligible because there is no significant change in the velocity or the elevation. There is also no work done as mentioned because there's no devices such as pump or shaft or turbine. Thank you.
So this is the reference. The first reference is for the function of pipe and duct. The second reference is for the application of pipe. The third reference is for the application of duct. And the fourth reference is for the tutorial question. And that's all for our presentation. Thank you.